Good morning. All right. We are going to pick up where we left off, which was section 4.4. I've got one more formula to show you there, and we'll do an example with that formula, and then we'll move on to solving some equations. So don't forget the 4.1 through 4.4 homework is due by midnight tonight, because like I said, this is the last thing I need to show you. So hopefully you've finished up most of that homework, at least through the 4.3 stuff. So hopefully all you got left is maybe a little bit of 4.4 stuff to finish up. If you've got questions about it, though, definitely send me questions through WebAssign, because I'll be responding to questions, checking email, that kind of stuff this afternoon. And I think that should be it. Any questions before we get started today? All right. So I'm trying out some new technology today, so bear with me. Be better in the long run, but it might take a few kinks to work out to make sure everything's working properly. So what we're looking at now is the change of base formula. Okay, so we've got a base b log of x, and what this tells us is we can actually change our base to any number we want to, right? So that a in the next part of the equation, that base of a could be any number that you want it to be, and then we're going to put the x from the log in the numerator and the b, the base of the original log, in the denominator. All right, so notice here the x in the original log, so this value here is going to match whatever this value is up here, and then this b value right here is going to match this b value right here. And then the a value itself, we can make anything we want it to be. Okay? Now, the reason this is useful is a lot of older calculators will not actually do a base 2 log, for instance, right, or a base 3 log. And so what we need is some way that we can change that base into something that we could put into our calculator. And so what we're going to be doing in a lot of cases is changing these to base 10, or a common log, or a natural log with a base of e, and then that way we can put it in the calculator. And I know a lot of like the TI-84 plus and above, right, those calculators will allow you to change the base anyway. And so if you can do that, that's fine, right? Just put it in the calculator as you normally would. But if you have like a TI-83 or older, and you can't put in those different bases, this allows us now to change the base to be able to put it into the calculator. All right. All right, so now if we look at this one right here, we have a base 8 log of 5, and what we're asked to do is use our change of base formula so that we can actually put it into the calculator and then simplify from there, right? So we'll put it in the calculator, we'll round it to 5 decimal places is what they tell us here. So if we look at this first one here, if I want to change it to something where I could put it into the calculator, again, we could use a common log or we could use a natural log. It does not matter. But what would this look like if I were to change the base and rewrite it in terms of a log over a log? All right, good. So we can change that to log 5 over log 8, right? So we've got log of 5 divided by log of 8, where we've changed it now to a common log with a base of 10, but that common log we can now put into the calculator. So let's try that. Let's see what we get, and we're going to round that off to 5 decimal places. We'll do log 5 divided by log 8. And so what should that give us if we round it off to 5 decimal places? Okay, so 0.77398. Good. And so that would be our answer this time. So again, this is just if you don't have a calculator that will actually let you put in that base 8 log of 5. We can actually use change of base here to change it to a common log, put that in the calculator. That'll give us the same answer. And like I said, we could use change of base using natural logs also. So if we were to do the natural log of 5 divided by the natural log of 8, okay, so try that. Just put that into the calculator, see what you get. And it should give you the exact same answer, right? And so that's why it doesn't matter what we change that base to, right? It's still going to give us that same decimal value regardless, right? So whether you want to use common logs or natural logs, it does not matter. Okay? We want to use something that we can actually put into the calculator. Any questions on that one? All right, so if we take a look at the next one now, how could we rewrite the base 9 log of 20? Good. All right, so the log of 20 divided by log 9. And again, you could have used natural logs if you wanted to, right? So either way is fine. Okay, but if we do that and we put that into the calculator, what should we get? So 1.3634. And then in this case, right, it is a 1, but there's a 6 after it. So I think that should round up, right, to a 2. Good. Right, so the 5 decimal places, that's what we should get there. Any questions on that one now? All right, so that is our change of base formula, right? And again, it's useful if we need to put something into the calculator that otherwise we would not be able to put into the calculator. And that's all we got left in the 3.4 stuff. Okay, so that's all we're going to do there. So now, move on to 4.5. All right, so this is section 4.5. So now we're going to start using these logarithms and exponential functions to actually solve equations. Right, and so notice here we've got exponential equations, 5 to the x equals 125, and we're asked to solve this. I'll give you a minute to get that written down. All right, so whenever you're given an exponential equation like this, and we're trying to solve for x, where x is in the exponent, what we actually want to do, first thing we always want to try, is see if we can get the same base on both sides. And what I mean by that is, could we rewrite 5 to the x or 125 so that they have the same base on both sides? Well, is there any way, in this case, 5 to the x, there's not really anything I can do with that, right? But is there anything I could do with the 125 to make it have the same base as what we have left-hand side? Okay, so 5 to the 25th, that would be really, really large, right? Because that would be 5 times itself 25 times, okay? But you're on the right track. So we want to write it as 5 to some power, Kenneth, right? So it's going to be 5 to the third. So I'm going to rewrite this, keep the 5 to the x, right? Equals, and then I'm going to make this 5 to the third power on the right-hand side. Any questions about how I did that? All right, now once we've done that, now if we have the same base on both sides, what that means is the exponents have to be equal to each other. Well, if that's the case, then what does my x have to be equal to? 3, right? And so at that point, we can just say, well, x has to be equal to 3. Since my bases are the same, my exponents also have to be the same, so that x value has to be equal to 3. So again, that's always going to be the easiest route to solve these if you can get the same base on both sides, right? And we will have some examples later where we can't do that, and we'll talk about what we do in those cases. If you can make the bases the same, do that, and then just set the exponents equal. Any questions on that one? Okay, all right, if we look at the second one here, we already have the same base on both sides this time, right? So both of these bases are 5. So what does that mean then? Good, right? So the 2x on the left has to be equal to the x1 on the right, because if the bases are the same, then the exponents also have to be equal here. And so now we just have this equation that we can solve. So what would you do to solve that? Good. Subtract x on both sides, and that's just going to give us x equals 1. And we could have moved the 1 over and then moved the 2x to the other side. In that case, you'd end up with a negative x, and then you'd have to still divide. And if you did that, though, you'd still get x equals positive 1, right? So either way is fine. In this case, it's probably easier just to go ahead and move the x just one step there. Any questions on that one? Anybody need more time to get any of that work now? All right. So here we go. So we got 3 to the x plus 2 is 7. Right? We're asked to solve that equation, find an exact solution, and then we'll use our calculator to get a rounded answer for that one too. All right. So if we've got 3 to the x plus 2 equals 7, again, the first thing we always want to look at is, can we get the same base on both sides? So is there any way I could rewrite the 3 or the 7 to make them have the same base? And the fact that I'm not getting any responses is a good thing, because there is no way that we can make those bases the same, right? I can't rewrite 7 to some power to equal 3. I can't rewrite 3 to some power to equal 7. So there's no way to make those the same. So now we need another strategy to help us figure out what x is equal to. So here's what I want you to think about. What was one of our properties that we've looked at in one of these previous sections that allowed us to get things out of the exponent? So what did we have to have there if we wanted to bring that exponent down out front? That's right. If there was a logarithm there, then one of our properties of logarithm said if there's an exponent, we can move it to the front. So what we're going to do in this case is we're going to insert a log into our equation so that we can then move that exponent out to the front and get it out of the exponent. Well, in this case, it doesn't matter what type of log we use. I could use a common log, a natural log, whatever I want. In this case, I would probably choose between those two just so I can put it into the calculator for part B. So I'm going to use, I'm going to use a natural log here. I'm going to take the natural log of 3 to the x plus 2 equals, but if I do a natural log on the left, I have to do exactly the same thing to the right. So I'm also going to take the natural log of the 7 on the right-hand side now. So whenever you have an x in an exponent and you can't get the same base on both sides, we're going to need to take a log on both sides so that then we can apply those properties of logarithms. Well, now that I've got the log there, what can I do? Good. I can move the x plus 2 out to the front. So that's what I'm going to do here and keep the whole thing together. So I'm going to put parentheses around it. We've got x plus 2 out front, the natural log of 3, and that's still equal to the natural log of 7. Now we need to get x by itself. So what could I do now if I want to try to get x by itself? Good. All right, so let's divide by the natural log of 3 on both sides. I can get rid of that. So divide by natural log of 3, divide by natural log of 3. So these are going to cancel on the left. And so that's going to leave me with x plus 2 is equal to natural log of 7 over natural log of 3. And then the last thing we've got to do if I want to get x by itself is do what? Just subtract the 2, right? And so now if I move the 2 to the other side, so I'm going to write it underneath here. So it's going to give us x equals natural log 7 over natural log 3. And then the minus 2 is just going to be separate from that because we can't combine it, right? It's not part of the natural log. And so that's going to be our exact answer for part A now. Any questions on that one? Just part A. All right, and then part B is just saying use a calculator, and it asks us to round to 6 decimal places. So we're going to put in exactly what we've got here, the natural log of 7 divided by the natural log of 3, and then minus 2. And so if we do that, what should that give us? Okay, so negative 0.228, and then 756 if we just need 6 decimal places, right? And so that should be good there. Any questions on how we got that? Now, the nice part, right, just like any other equation, we can actually substitute that value back into the original equation and make sure that it works. Now, we've rounded this off, so it may not be exactly 7, but if you were to do 3 to the power of negative 0.228756 plus 2, right? In my calculator, I get 7.0000001929. Okay, so it's really, really, really close to 7. If we had kept all the decimal places there, right, it should give us exactly 7 when we put that into the calculator. But always keep in mind, right, if you're unsure of your answer, you can always go back and plug it back in for x and make sure the equation is still true. Anybody need more time on that one? All right. Let's take a look at this one. All right, so same thing. We're trying to solve for x. So what do you think we might want to do first here? Try to get x by itself. So good. So we are going to put it in log form. Now in this case though, there's one thing we're going to have to do before we can do the logarithm on both sides. And that's because we have this extra coefficient out front before the base. So we always want to get rid of any coefficients first, and then we can insert the log. So how are we going to get rid of that coefficient? Good. So we're just going to take both sides and divide by 8, right? Since the base this time is the e, right? The e is what's being raised to the 2x. We need to get rid of the 8 first, and then we'll go in and insert the log. If I divide by 8 here, that's going to give me e to the 2x equals, and then 20 divided by 8, right? You can either leave that as a fraction and simplify it, or if you want the decimal, that's fine. And I'm just going to go ahead and write it as a decimal, so that'll be 2.5. Now that we've gotten rid of that coefficient, now we can do what? Okay, good. So put a log on both sides. Now, what type of log do you want to use this time? Good. In this case, it makes the most sense to use a natural log since our base on the left-hand side is an e anyway, right? We know the base of the natural log is e. So let's take the natural log of both sides here. So we're going to end up with natural log of e to the 2x equals the natural log of 2.5. Right. Now, once we've done that, now what can we do? Good. We can bring the 2x out front. So we've got 2x natural log of e is equal to the natural log of 2.5. Now, we just need to get x by itself. In this case, though, what is the natural log of e going to be equal to? Yeah, right. You could think of it as they cancel out, right? We have a property that says that the natural log of e, since the base is e and we're taking the natural log of e, we're going to end up with 1, right? So this thing right here, the natural log of e, just becomes a 1. And so we just have a 2x on the left-hand side now. We could have done that from the previous step because we had another property that says if you have the natural log of e to some power, the answer is just going to be the exponent. So we could have just put 2x there to begin with. All right, so now if I want to get x by itself, what do I need to do? Just divide by 2. Good. All right, so I'm going to divide both sides by 2 here, because the 1's not going to affect anything, right? That's still just going to be 2x. And so now when I divide by 2, I get x equals natural log 2.5 all over 2. And that is an exact value. Don't try to divide the 2.5 by the 2 because one's inside the log and the other is not, right? So that's as much as we can do to simplify that. And then if they ask you for a decimal answer, then just put that into the calculator, round it to however many decimal places they tell us. But in this case, since it doesn't say to round, we're just going to keep that exact value there. Any questions on that one? And just like I told you on the last one, if you're ever unsure of an answer, right, we can always take that x value, plug it back in for x, put all that into the calculator, and then just make sure in this case that it's equal to 20. All right. Let's look at this one. Okay, so this time they say we're going to solve it algebraically and graphically. So we'll solve it algebraically like we have before, and then we'll take a look at the graph, and I'll show you how we can actually check our answer using the graph. All right, so if I want to start getting x by itself here, what's the first thing we're going to have to do? Okay, good. This time there is no coefficient, right? So there's nothing to divide by. So we're going to go ahead and take the log on both sides. What kind of log do we want to use this time? Good. Let's make it a natural log, right? So let's take the log of e to the 3 minus 2x equals natural log of 4. All right, now once we've done the natural log on both sides, now we can do what? Good. So move the exponent up front. So again, I'm going to keep all that group together. So 3 minus 2x times the natural log of e equals natural log of 4. What can we do from there? Good. The natural log of e is just 1, right? So then that's just going to leave us with the 3 minus 2x equals natural log of 4. And now it's just a matter of getting x by itself. So we would do what first? Okay, subtract the 3. Then we got negative 2x equals, again, don't try to combine these because one's inside a natural log, the other is not. So this is still just natural log of 4 minus 3. And then we can do what? Good. Divide by the negative 2. So that's going to give us x equals natural log of 4 minus 3 all over negative 2. Any questions on any of those steps? All right, now we are going to look at the graph of this one, right? And our graph's only going to give us decimals. So let's go ahead and get an approximation for this one. So put this into the calculator, see what you get. And 4 decimal places should be good. All right, so let's see. So you did, just double check my answer because I got something different from that. So I think what happened there, make sure that you're doing the entire numerator first and then dividing by negative 2. Because if you just try to put it all in there, it's going to just divide the negative 3, negative 2. Good, right? So if we do it that way, where we group the entire numerator together, we should get 0.8069, round that to 4 decimal places. And that should be sufficient here just to kind of check ourselves on the graph. So again, if you're going to put it into the calculator, just group the numerator together before you divide by the negative 2, and that should give you that answer there. Any questions on how we got that? All right. So I'm going to graph this in Desmos. And so what I'm going to do is I'm going to graph the left-hand side of the equation as one function. So that's going to be e to the 3 minus 2x. I'm going to graph y equals 4 as a separate equation. So let me share this. So that's what our graph looks like. So the e to the 3 minus 2x, that's that red graph, the curve. And then y equals 4 is just going to be a horizontal line at 4. Now, if we're looking for where these are equal to each other, what are we trying to find? The intersection, right? And so all we want to do is click on that point of intersection here in Desmos. And so that tells us there 0.807, we got 0.8069, right? So they're rounded to 3 decimal places, right? So that is our answer. So again, that's just a quick way to kind of check to make sure that our steps here, when we solved algebraically and we got our answer, right? Just graphing it real quick, finding that point of intersection will tell us if we did it correctly or not. Any questions on that? Right. All right, so let's take a look at this equation now. All right, so what's different about this equation compared to some of the other ones we've looked at so far? Okay, so one side is 0, right? So it is set equal to 0. That's one thing that's different. What else is different? Okay, it decreases in the exponents. There's 2 e's, right? And so in this case, notice the big thing is that we have an x in this exponent and we have an x in that exponent, right? So we don't just have an x in a single exponent like we did on the other ones where we could just say, oh yeah, let's just get that base by itself, then we'll take the log on both sides. There's no way to get those by themselves because it's in 2 different terms this time. So what we're going to have to do here, and notice here it says this is what we call a quadratic type. So we're going to use factoring, right? Just like we would if it was a quadratic x squared plus 2x minus 3 or whatever, right? We're going to use quadratic and factor. So let's think about how we could factor this trinomial right here into 2 binomials. Right? And it's already set equal to 0 for us, so we don't need to do anything there. If it wasn't, you would always want to get 0 by itself before you start factoring. So let's think about the first term here. What could I multiply to give me e to the 2x? Okay, so e is that e squared times e to the x, I think is what that's supposed to be. So let's think about that, right? If I did e squared times e to the x, what's our rule for multiplication now with exponents? What are we going to do with the exponents? You would add them, right? And so if I were to do this, that would actually give me e to the 2 plus x instead. So what would that need to be if I actually want to end up with 2x instead? So e to the x times e to the x, right? Because if I did e to the x times e to the x, now I would keep my base of e, add the x's together, and that would give us 2x. Does that make sense? And so in this case, that means we're going to have e to the x here and e to the x here, because then when I multiply those together, that's going to give me that e to the 2x that I want. Okay? Now, at that point, we just look at the 6, right? Because we need to find factors of 6 that will also give us a negative 1 e to the x in the middle. So what factors could we use here? Okay, 2 and good. I'll put the 3 here, the 2 here. And then what about the signs? Good. 2 is going to need to be a positive, and the 3 is going to need to be a negative, so that once we distribute this out, right, e to the x times e to the x, that's going to be e to the 2x. Outer terms here are going to give us plus 2 e to the x. Inner terms would give us minus 3 e to the x. And then negative 3 times 2 is going to give us the minus 6. And then when we combine these inner terms here, 2 e to the x minus 3 e to the x, give us that negative e to the x that we want in the middle there. Now, once we know that, now we have our factors. Now if I want to solve for x, what am I going to have to do? Good. Set each factor equal to 0. Right? So we're going to take e to the x minus 3, set it equal to 0, and then we're going to take e to the x plus 2, and set it equal to 0 also. Right, so then for the first equation here, what would we do first for e to the x minus 3? Add the 3, so that's going to give us e to the x equals positive 3. And now we would need to do what to get x by itself? Natural log. Good. So we're going to take the natural log of both sides. And so what's that going to give us on the left-hand side? Just x, right? Because the x would come out front, but the natural log of e is just 1, and so that's just going to leave us with x equals natural log of 3. Any questions on how we got that one? All right, what about the other equation? What would you do first? Okay, subtract the 2. So now we have e to the x equals negative 2. Then you would do what? The natural log of both sides. Good. Now we have, what are we going to have on the left-hand side now? Good, so x equals natural log negative 2. Now, here's what I want you to think about. What is the natural log of negative 2 going to be equal to? So what do you get if you put it into your calculator? Undefined, right? Okay, so you can't take the natural log of a negative number, right? So negative values are not in the domain of a log function. And so in this case, if you ever end up with a log of a negative value, this right here does not exist. And so it's not really a solution. So our only solution to this equation now is going to be x equals natural log of 3. So just keep that in mind. If you ever get a log or a natural log or a base 2 log, it doesn't matter what kind of log it is. If it's a log of a negative value, it's undefined, and so we only want to take the x equals natural log of 3 in this case. Any questions there? All right. Let's look at this one. So again, we've got one where we have x's in multiple exponents, right? So we can't just isolate and take the log of both sides. We're going to have to do something else this time. All right. Any thoughts on what we might be able to try first here? Good, right? So we're going to look for our common factor here, right? And so what's going to be our common factor between those two terms? Good, x times e to the x. So I'm going to take out the x and the e to the x. Now let's think about what's going to be left over here. So if I take out x e to the x, what are we left with? Good, so just 3 from the first term and just an x from the second term. So 3 plus x. Well, now that we've got this thing factored, now we can do what? Good. Okay, so set the factors equal to 0. How many factors do I have here? 3. Okay. What's my first factor? X is its own factor, right? So I have to set x equal to 0. Then I'm going to take the e to the x and set it equal to 0. And then I'm going to take the 3 plus x and set it equal to 0. So even though I took out the x and e to the x together, those are two separate factors, right? So just make sure that multiplication, you're breaking it up when you're actually setting each one equal to 0. Well, the first one's solved. X equals 0, that's already solved, nothing to do there. What about e to the x equals 0? What would we do with that one? Okay, we could take the natural log of both sides, right? The natural log e to the x equals natural log 0. Left-hand side just gives us x. What's the natural log of 0 going to give us? Undefined, right? Okay, because remember again, a natural log has to have a positive value on the inside because there's actually an asymptote at 0, right? So 0 itself is undefined, so we don't get any solution from that piece right there. And then if we look at the last piece here, how are we going to get x by itself? Good. So we just get x equals -3. And so our only two solutions this time are going to be the x equals 0 and the x equals -3, because that e to the x piece just gives us an undefined answer. Any questions on that one? All right. All right, so this kind of ran all together. Let me see if I can fix that. Maybe not. There we go. All right. There we go. So now it's all in one line. Okay, so I'll give you a chance to write that down. All right, so let's think about what we could do here, right? So now we have a logarithmic equation. So think about all of our properties of logs and what we might be able to do here to help us solve this one. What do you think we might want to do first? Okay, good. So how would we combine, in this case, right, the one on the left, right, is already a single log. So let's just talk about combining the ones on the right. How would we combine the logs on the right? Multiply, right? So remember we said if there's addition here, when we put those together into a single log, as long as they have the same base, we're going to multiply what's inside. So I'm going to have log of x squared plus 1 on the left equals the log of x minus 2 times x plus 3 on the right. Now, once I've got those combined, what could we do from there? We can remove the logs, right? Since I have a log, a base 10, a common log on the left, and a common log on the right, we know the stuff inside those logs has to be the same now. So I can just drop the logs and say x squared plus 1 has to be equal to x minus 2 times x plus 3. Right? And that's like that problem we did where we were solving for p and we got the logs on both sides and we said, oh yeah, if we have that, then we can drop the logs because the stuff inside the logs has to be the same. Well, now I'm just trying to solve for x, so what can we do from there? Okay, so you could subtract the x squared and the 1, right? Let's go ahead and multiply out what we have on the right-hand side first, though, because that way we can start combining any like terms. So I'm going to keep it for now. X squared plus 1 equals, if I FOIL the right-hand side, x times x is x squared. I'm going to have a plus 3x and a minus 2x, so that's going to be a plus 1x. And then a negative 2 times 3 is going to be a minus 6. Now, at that point, I actually have an x squared on both sides. If I subtract x squared from both sides, they're both going to cancel out, and that's just going to give me 1 equals x minus 6. And then we can just do what? Yeah, just add 6, right? And that's going to give us 7 equals x. And that is our answer. So once you get rid of those logs, just think about, all right, I need to simplify what I've got here, combine any like terms, and just try to get x by itself. If your x squared had not gone away, then you'd probably want to move everything to one side and see if you could factor. But in this case, right, the x squares do cancel, and so you can just get x by itself pretty easily. Any questions on that one now? I know we're over time. Just real quick with either a yes or a thumbs up. Was this better than what I have been doing in the past with the camera above and trying to write? Is this clearer, easier to read, or overall? Good. Yes. Yes. Okay. I'm going to continue using this. Perfect. Yeah, because I think this should be a little bit clearer for you. If you ever still can't read anything, let me know. If the colors aren't good, let me know because I can definitely change those up. But I'm going to definitely be using this because I think overall this should be a lot easier to read. All right, good. Well, like I said, homework due tonight, so don't forget that if you haven't finished it already. Ask me questions if you have any through WebAssign. I'll be checking those questions this afternoon. But otherwise, have a good afternoon, and I will see you tomorrow.